Hi everyone, and welcome to Data Analytics, Programming for Data Analytics Part 2, DA 621. The topic of the day is going to be regular expressions. So before I tell you what they are and how they're useful for us, let me give you some motivation by telling you when you would want to use these magical regular expressions. So let's put a scenario. This being a Programming for Data Analytics class, you are more than likely going to want to use the tools that you learn here to do some sort of data mining, or in general to be able to discover information from multiple sources. And one of those sources is probably going to be just text. Lots and lots of text. So what am I talking about? Well, okay, suppose that you are scanning in thousands of pages of like legal reports. And you got them all in the computer, so you got all the reports in your computer, and they're nice and well kept and everything. And now you're trying to search from them specific keywords of things that interest you. Okay? As an example, let us say that you wanted to find out how often a specific word is used. So maybe you are looking at a lawsuit, and you want to find out how many times they mention a specific piece of evidence. Okay, let's just say the specific piece of evidence is a phone, a specific phone, Samsung Galaxy. Okay, so you're looking for the word Galaxy, and you want to find out not just everywhere it appears, but like what the context is. So with the knowledge that you learned in DA 621, you know that you can import all of those texts that you have that you're trying to look through by opening them with Python. You know, opening a file, loading the data in, and then once you have it all in some massive string or something, or a list where you separate each word, you tokenize each word, then you can go ahead and maybe put this in the loop and then start processing it, right? And if you want to find out where the word galaxy is in the text, you could just as easily just loop through everything, say like for I in A, and A is your entire list of words, and see if you know, put in if I is equal to the word galaxy, then you found a match. And when you found a match, then you can go ahead and maybe pull out some text from before and some text from after the match. And that could work. However, it may not be as efficient or as fast as it can be. And furthermore, if you start going a little bit more fancy with what you want to find, like maybe you want to, because right now you're doing exact matches, but like what if galaxy is spelled with uppercase or with lowercase, and you want to have variations? Well, you could use something like lower to lowercase everything, so you have all matches regardless of the case. What if it's misspelled? What if you are trying to find some similarity, like galaxy, but it can accept like up to one letter being incorrect? Of course, you can go on and kind of make the query of what you're looking for being a little bit more complicated. And so when you're approaching something like that, you could go and write some really complicated code that checks all the different variations of this and gets it working. Or you could use some of the available tools out there to make your life much easier. One of those tools is going to be the concept of regular expressions and the libraries that are available in Python that can use regular expressions to do these kind of searches. And so that's what regular expressions are. They allow you to sort of formalize what it is that you're looking for in a bunch of text, so that the library can search for it extremely quickly and be exact as to what you want. That's, of course, the ideal. However, it's a lot harder than it sounds to achieve this, because to be able to communicate with the regular expressions library the pattern that you're looking for, you have to understand the own little syntax and rules that the regular expression library uses. And this is not strictly just for Python. The regular expressions are very popular in computer science, and they're used throughout a lot of programming languages, and they all have their own implementations. So this applies not just to Python, but just about anything. And so understanding how to use regular expressions in a way maybe not this big, but in a way, it's like learning a programming language. You have to learn its own sort of keywords and rules and how they work. And so because of that, obviously, it's something beyond the domain of something that I can just cover in a couple of lectures. So while I'm going to introduce you into regular expressions and go over some of the basics, and we'll do some pretty cool queries, understand that your knowledge is from here to here, but there's still like way up there of stuff to learn. So if my best approach for this is that if you're interested in knowing more about them, then you can always go out and research more, or you can also wait until you actually need to use it in a certain scenario, and then you can learn at that time, like, oh, okay, I know how to do this, but like now I want to do this plus this. Well, Google it, and I'm pretty sure you'll find someone that has done something similar, and you can learn from that experience, and then in the future you know how to do it. And so that's how I think you can grow. So while it is cool to also just kind of on your own to try to learn more, I prefer that way of learning of like, as I go, if I need a tool which I know some information about, but I'm not an expert by any means, then I take this as a learning opportunity to expand my knowledge of the tool as I use it in that specific scenario, and basically keep building every time I use the tool. And it also basically makes my brain more efficient, and like, this is information that I actually need and is relevant to me, versus like, hey, let me learn a tool that I may or may not end up using in the long term. Okay? So before I just go in and like say, okay, this is how you do this and this and this and that and regular expressions, let's talk a little bit about formal language theory. Okay? Now it's going to get a little computer sciencey, but I'm going to keep it to the bare minimums, since at the end of the day, this class is more about learning the tools and using them than really learning a lot of the theory. For that, you'd have to take like an automata class to understand, all these fancy things that we're doing, okay? So let's go back to the basics, just to make sure we're on the same page. Let's talk about Boolean algebra, okay? So we know when we have Boolean algebra, we have sort of three main things that we need to know. We have and, or, and not, right? So we know that if we are anding two things, so if we have our little truth tables, we know that something and something else is going to be true if both pieces are true, right? In other scenarios, for example, if something is false and something is true, in either of the two cases like this, or both things are false, if we're anding them, then for all of these three scenarios, you're going to get false. That's the and. The or, on the other hand, basically, well, here, let's just go ahead and put it out. So for or, as long as one of them is true, then the statement becomes true. So for all of these, you're going to get true. So let's put the equal sign there. It looks cleaner that way. The only scenario where the and clause, or sorry, the or clause is going to evaluate to false, and so when both statements are false. Finally, we have the not, and the not just basically flips whatever a statement is. So if something is true and then you not it, then it becomes false. And if something is false and you not it, it becomes true, right? And in programming, we have a lot of different terms for these things. Typically, you'll see something like a dot and a plus, or a multiplication. You'll see ampersand sometimes. Well, that's like in C++. You'll see that vertical ends for or, and for not, you typically see the exclamation point. For Python specifically, we see the lowercase and, lowercase or, and either the like not, like that, yeah, or not like that, yeah. Okay, so that's our Boolean algebra. And I wanted to review that as basic as it seems, because at the end of the day, if we don't know these basics, then the rest of the stuff is just going to get a little confusing than we want it to. Okay? So having explored basic Boolean algebra, let's also refresh a concept that we learned when we were first learning about strings and variables in Python. And that concept is the concept of concatenation. concatenation. What is concatenation? You all know, but I'm just going to repeat it anyways, right? So if we have two strings, you'll see typically the plus sign in Python used for this. That means that we're basically taking both strings and gluing them together. So if A contained the word hello and B contained the word world, the result of this concatenation would be hello world without a space. There's no space because they don't have a space. If you put a space, then there'd be a space there, but there's no space in either one. Right? So that's your concatenation, and it's useful when you're trying to like assemble a string out of other strings, right? Very, very, very useful tool when you're formatting output or opening a file and appending, like concatenating like an extension or something. So lots of uses for those things, okay? So why am I reviewing these things? Well, because if I'm going to explain to you a little bit about formal language theory and regular expressions, I need to explain to you a little bit about grammars, okay? So let's talk a little bit about regular grammars and how they work, okay? So a regular grammar is a way of representing a set of characters, okay? And these characters are going to be literal characters. Now, what do I mean by character? I'm talking about the alphabet, like A through Z. But in theory, you could do any symbol with this, as long as it's a finite, like a finite set that you're giving it. But you know, since we're talking about strings, the best example of what the list of characters is going to be is what the ASCII table is going to be, right? And the ASCII table is made up of the letters A through Z, uppercase and lowercase. Numbers are in there as well, and there's a couple of special characters like dot, asterisk, semicolon. Basically everything you see if you look at a keyboard. And I know you're watching this on a computer. Well, actually, you could be looking at a tablet. But if you're watching on a computer, just look down and look at a keyboard. And all the things you see there are characters that are probably in the ASCII table for the most part. Obviously, nowadays, with different languages, there's Unicode and things that are bigger than the ASCII table, so we can fit like special characters. You know, just for now, think simple, think ASCII table. Okay? So that's what I'm talking about with a literal character. And so what you're trying to do with grammars is you're trying to sort of give like order to the world. And so I'm trying to give order to explain a rule set that is going to define all possible, you know, combinations of letters that I want in my universe. Obviously, if you're looking at something like the English language, then you could say that all the combinations are going to be combinations that actually make valid words. But it could go beyond this into any kind of pattern that you want. Okay? So let me go ahead and give you an example of a grammar. Okay? So I'm going to go ahead and just go and do like one or two examples. And then I'm going to go ahead and explain what the symbols mean. Kind of explain backwards. Because if I feel like if I just give you the examples first, some of them might not make sense until you actually see an example of like it being used. So, you know, suppose that I go ahead and write that. That's good enough for now, okay? So if I say that I have a grammar and this is the one and only rule that you have for the grammar, what does this mean? Well, to understand what this means, we have to understand what this vertical line means, okay? This vertical line represents, or just like we were kind of doing in the Boolean Algebra, okay? And so, in a way, it's going to basically be, you are going to either pick one side or you're going to pick the other side, okay? So if I am trying to, if this is my rules, it means that I could either have the output be an A or the output to be a B, okay? But I cannot have both being in there, okay? So another term for that, you'll see if like you look at like Wikipedia, would be alternation. think that's a more formal definition of that. But yeah, that's kind of what that is. Okay. Another example of that, of a grammar, I suppose, not that grammar, is something like this. What is this? Well, we got two literals here, and there's nothing in between them. So what do? Well, if you just got them together like that, then they're just being concatenated, so it's just going to be A and B. Problem solved. So in a way, that's concatenation. However, you don't always have things in literal terms. Think back to math and set theory, and I know you know a little bit of sets because we did talk about them in 621 when we're talking about Python, so that's my excuse for not spending an hour on sets. But suppose that I have the following set. So I'm going to go ahead and define set R to basically contain a couple of letters in it. So maybe like A, B, and then like maybe a D in it. And then I'm going to denote another set here, S, that is going to contain maybe just for now an E. Let's put one more letter, that's interesting, and a G. Okay, so if I have these two sets like that, and I go ahead and use the OR, and I say R or S, and I ask you what would this generate in terms of the output, then it could be any of these. So it could be, so like what is the dictionary of words that could go in here? Well, it could be AB, it could be D, it could be E, and it could even be G. And I made that sound like even, as if it was like special case, but it's not. Okay? So what I'm saying is it could be one or the other. However, each of these has multiple options. So it could be this, this, or this, or this. Not very exciting, but what if I did instead RS, like a concatenation? This one is cool. So the possibilities here would be to take the first one of the first set, A, B, and then concatenate it with one of the two of the second set. So that could be something like ABE. It could also be ABG. It could also be taking something from the second one, so D with E, and it could also be D with G, right? So basically, the order matters though. So I have to take something from set R, so this or this, and then take something from set S, so this or this, and basically glue them together. I don't do both though, I just take one of them, okay? And so those could be any of the combinations that you see up there, potentially, okay? So that is going to be your concatenation and your alternation. And there's one more that I want to show you. So let's go ahead and erase. Well, I mean, you can always take a screenshot. So let's just erase this right here for now. So there's one more possibility. Let's go back to just using a literal. And let's just say we do star. Okay? So the star is actually known as the, I'm going to say this wrong, but it's clean star. It's kind of like Kleenex, I think. So it's not an asterisk per se, it's a clean star. And the official term, if you look at something like Wikipedia, it's like denotes the smallest superset of the set described by R that contains the empty set and is closed under string concatenation. Okay. In layman terms, what the star is going to do is it's going to basically be any number of arrays that you want. So it's kind of like a loop. However, that also includes, as you can see by the definition there, that contains the empty set. Okay, what is the empty set? The empty set, as the name sort of implies, is when there's nothing inside. When it comes to set, and you can all kind of look more into this. There's a difference between like a null and like an empty. Empty just means there's like nothing in it, but it's still a set, and so that's kind of important. Otherwise, like unions and things like that break. So what we're saying here is that this literal with the clean star, the resulting dictionary of things that could be in here could be nothing, so that's the empty set. It could be a single A. It could also be two A's. It could also be three A's, and all the way to basically, I suppose, like an infinite number of A's. So that's what the clean star does. It basically just takes what you have and repeats it as many times as you want. It doesn't list how many times something repeats. So because of that, whenever you see a clean star in a language, it means that your list of possibilities is endless or infinite. So yeah, that's also pretty cool. So what you do is you combine these things together to denote a very specific combination that you are looking for to create in a language. Okay? So what I'm going to do now is I'm just going to go ahead and show you some examples of that. All right, I think that's good enough. Okay, before I do that, let me I might have said empty set when I meant empty string earlier with a clean star. Yes. Ooh, I screwed that up there. So actually, when I say that this can have 0 or more characters, technically speaking, there's a difference between the empty string and the empty set. The empty set would be this symbol, and it would literally be a set that's empty. Okay? However, if you're looking at the empty string, and you will see this symbol typically used, that contains a set, technically, that has like nothing in it like that, but it's still a string, but it's empty. Like think of like Python, when you want to initialize a string variable with like nothing in it, you still put the little quotes, but you just put no space in between, right? Or no characters. That's the empty string. So the clean star can generate the empty string, and then it can also generate any number of letters of the A. Okay? So the result of this would be empty string, an A, two A's, all the way to an infinite number of A's. Okay? So important. So I apologize for confusing that, but I'm glad that I caught it. Okay? So now that we clarified that, let's go ahead and do some examples with literals and also with like non-literals. Okay? So if I say AB with like the clean star, for example, what would that give us? Well, that could give us the empty string because we got to pick either this or this. So in one scenario, if we're picking the left side, the only option that we would have out of that would be just an A, and that would be it. But we can also pick on the right side instead of the left. And for that one, we can have the empty string, like we said. I can write it like this, or I can use this symbol instead. So let me just go ahead and use that symbol just for sake of differences, not to get confused. And then you can also have one B in there, two B's, and so on. Okay? This should all be all quoted. All the way to infinity. So technically, this set is infinite in terms of members. Okay? So yeah, that's cool. Let's do something with parentheses. So, what would be a good example with parentheses without confusing everyone? Let's just do... Well, here, let's do this example, the one from Wiki. I'm trying to do different examples in the Wiki, but these are pretty good. Ah, wait. Put this outside. Okay? So, in this case, as you can see, the clean star is outside of this. So, we know that if there was no clean star, so like if we just had that it would, the resulting grammar would be just A and B, right? I mean, so the resulting dictionary that you create. By doing this, it's like adding that looping, so that infinity. So we're basically going to pick one of these and then rinse and repeat forever. Okay? So potentially, the language that you could come out of this would be, and also remember that when you do the clean star, you could also pick the empty string, so you could end it there per se. If I just pick the empty string, then that's all I'm going to get. So that's the first option I guess you could do. Another option is that you could pick the left side. So let's say you pick the left side, A. After that, you go back to the sort of clean star, so you got to loop again. So this time, let's see, you pick another A. Then you go back, and let's say you go in. So you pick a B. You go back, and now this time you pick a B. And maybe now you pick an A. And you can keep going back and forth for infinity with just one single string with infinite number of characters in it. However, you could also pick the empty set at this point. And so that would end it. Now, I keep saying empty string. So that would be the end of that. Okay? So what you're really achieving with the parentheses and the clean star is you're basically saying choose any of these any number of times until you want to stop. Or you can never stop if you want and just go on forever. Okay? So that's a good example of the parentheses that I can think of there. Yeah, let's leave it at that one. Okay, I think I'm going to stop there with examples. Let's do one with a non-literal that represents literal. So like earlier I was saying like R, and I would have like an A and a B. So if I say something like that, that's kind of the same thing as doing that. Because you can pick either one of the two and then repeat it afterwards. So yeah, that can work. So why would you do this weird notation and stuff? One thing is the ability to explain an entire like grammar with very little writing. So like if I'm trying to generate a pattern and I can actually come up with the rule set to generate that pattern, which like could be multiple of these or like one of these, then I am able to like create something that would otherwise take an infinite number of storage, because it could have an infinite number of variations, and store it in like nothing, like 5 letters there. 5 symbols, 1, 2, 3, 4, 5, 6 symbols. So, you know, compactness is a very powerful thing when it comes to this. And the ability to just say a lot with very little. So, why is that useful for us? Well, because we are trying to search for specific strings, specific patterns. And we want to be able to express that patterns using this kind of logic. Okay? And so regular expressions are sort of born from this. However, don't worry if this is not making a lot of sense, because you're not going to be using this. I mean, this is available, but there's a lot other more tools available when it comes to actually using regexes in Python and other languages. Okay. So from here, let's move on to actually using this. Okay. So let me pull up the list. I don't know these all by memory, so I have to have a list for them. Like I said, next time we'll actually play with while having Python in front of us. Excuse me, to actually be able to run these. But if you want to play with it right now as you're following along with the video or in the lecture, I welcome you to try just the most basic example. Well, actually, first of all, try to see if you can import the library. So to import the regular expression library, we want to say import RE, which stands for, wait for it, regular expressions. Okay? So, like I said, I'm going to show you the basics of this, and next time we're going to actually try it out on the computer. And, you know, I'll do it like I do all the other lectures where I have my my iPad, and we also have an interpreter running, so we can just go back and forth. Because here it's a little, I mean, I can run Python code, and I do have it set up so I can actually pop up here some Python, but I'd really rather avoid that because it won't look optimal. And then I have to slouch down to code. It's not very comfortable. Okay, so import RE. Actually, let's change colors. All right, so let me switch over here. We've all been hearing how popular the metaverse and meta and all that terminology keeps coming up in social media and finance and everything, right? How it's going to be the next big thing, all this, the meta and whatnot, right? So guess what? Even though this regular expression stuff is like pretty old, like 50s, I think, or 60s, one of the things that they use are what is known as the meta characters. So we have to embrace the meta, I suppose. Okay, so what we're going to be doing with the regular expressions is I'm going to show you what the different characters are that do different things. So, for example, you know, you already saw like with regular expressions that this is going to be your or, and then you saw like the clean star, right? So if you're coding on Python and you just try to put in the clean star, it'll work. It'll work. So like, you know, if you were writing the following regular expression, and you said like hello, and then you did like that, I believe that would allow you to basically repeat the asterisk, repeat the exclamation point as many times as you want, because that's sort of the clean star. However, actually, does it go before or after? Let me check that. I think okay, so in this case, actually, what you would be searching for, because remember, regular expressions are for searching, it would be searching for the word hello, followed by 0 or more characters, followed by an exclamation point. That's what it would mean, yes. Okay, so let's go ahead and look through all of these. And I'm going to sit down for a little bit, because my stomach hurts actually, because I ate too much for dinner. So I apologize for that. Okay, so you're searching for things. So what we're trying to do with regular expressions is we're trying to search for patterns, okay? So suppose that we want to find an exact pattern. Well, we would just say look for this word, right? But we're trying to do fancier things like that. And with the power of regular expressions, we can, such as like find patterns that contain this or more characters, or this character within a bigger or statement, things like that, okay? So, for example, let's say that we're trying to find a set of characters. You would use the hard square brackets, and in between, you would put the list of characters that you're looking for, okay? So, for example, let's say that you would like to search for all characters between the letters A and G. So you could say A through G with a dash. And what that's going to do is, you got to remember your ASCII table. It's going to go from A through G, and it's going to look for all the characters that are alphabetically between them. Okay? So, in this case, it's as long as somewhere in your text that you're searching, there's one of these letters, it's going to flag it. Now it's not going to do you a lot of good because that's like half the alphabet of words in there. Well, not half, but like a third of it. So that's going to be quite a bit, and you probably don't want that much. Okay. However, you're going to do this in combination with other things. Okay. But that's the first one. So that's your set of characters. All right, moving on, let's talk about that clean star since we were doing it. So if you see this as part of the string that you're searching for, that is going to be just like the clean, it's going to be 0 or more occurrences. Why 0 or more? That again comes in from regular expressions because it includes the no string as well, okay? So like I said, that example, so if we're looking for a string that contains like hello, and then this clean star, and an exclamation point, what is happening here is you have to find within your string that you're searching through, your text or whatever, you have to find the word hello, and then you can have 0 or more characters after this, and then you have to find the exclamation point. Okay? So ultimately, I'm saying a pattern like this would be found. A pattern like this would also be found. This would also be found. This would not be found because, sorry, my apologies. That would also be found because that's 0 or more characters. So these would all be found. What would not be found? I suppose. Well, okay. Well, how about this one? Would this one be found? And the answer is no, it wouldn't be found. Because this part would match, and then this would match, and then 0 or more characters. So like these would be considered 0 or more characters here. So that would be actually okay. But it needs an O right here for that to be found, I believe. Possibility that I might make a mistake as I'm going through these. But I'm doing my best here to try not to, because sometimes this stuff can get kind of trippy. Okay? Basically, it has to match the word hello entirely and then fill things in here. The one that would match but may not seem so obvious that it would match would be like this. Like that. And of course you could also have some text over here. It would match this part. Then all of this would be the asterisks. And then finally this would match. Okay? So why would you do this? Well, let's say that you were trying to find text, that would match between like two keywords that you care about. So like, somewhere in here you have the word like finance, and then somewhere else you have something like Galaxy, because you're trying to find something related to Galaxy's finance. But you want to see what's in between there. Well, that would be what this asterisk would give you. However, technically speaking, as long as like, if like 10 pages down the line here, you know, like you have, like let's say you have a hello here, and then you have 10 pages of stuff, and then you have an exclamation point, that whole 10 pages would actually match with this, because that's 0 or more characters. So this may not be as refined as you wanted so far. And that's the trick with regular expressions, that you have to really think about how you're doing these, because you may get unwanted results if you're not actually careful with them. You have to formalize them. You have to test them. You have to make sure that the math is right. All the set stuff. Otherwise, like I said, you might get some false positives, or you might miss things. Not because this is wrong, like regular expressions are wrong, but because your regular expression was poorly made. The semantics of it is not what you intended. Okay, so that's your set, and that's your clean star, which is the asterisk. Beyond that, we have a couple of other ones that we want to see. So let's start with the dot. So the dot can be any character, with the exception of new lines. So it kind of works like the asterisk, but not quite, because the asterisk is looking for 0 or more occurrences, whereas the dot is basically anything. Okay? So, like, I don't think the star, well, would the star be okay with spaces? I have to test that one, actually, to figure out what that would take. Let me see. No. I know. Yeah. Any character. Okay. Yeah. So the asterisk, like I said, can be 0 or more characters. The dot is more like a placeholder. So the dot is going to, it's like a placeholder for a single character. It can be any character, but it's a single character. Okay? So it could be useful for things like you might want a variation of spelling. So for example, let's say that you are looking at the word potato. Okay? We know that potato, you know, some people put the E on it, sometimes they don't, right? So let's say that you're looking for like potato where you don't care what this O is, okay? If they put like potato, potati, or potato or something, or just potato, I don't know, then what you do is you use a dot. And this is just like a period, not like a middle dot or something, okay? And that would be your expression. So this could be anything except like a new line, so no line feed. It could be a space even, like you could even just have a potat space E, okay? And that's what that's gonna stand for. When can that be useful? Like if you you know, if you're looking for like some information with numbers, like identification numbers, you know. So like let's say that you have a database and you got all the files from it, and like you're looking for some serial numbers, and you're trying to find out like all the serial numbers that are within a certain range, like between numbers MXT 5000 or 50,000, sorry, and like maybe 59,000. Okay, like maybe that's the range of numbers you're looking for. Well, the regular expression that you would write for that would be mxt5.000, and that would work kinda, but you would also might get some unwanted things such as 5a00 if those are actually part of your database. Like that could be a combination, because that's really going to give you anything that can be there. Could even give you one where there's just a space in there. Okay. However, if you're specifically looking for a set of characters, we're going to see that in a minute here. Okay? Actually, you already saw that. Yeah. You could use these guys for that, right? Set of characters. So you could put in there 0 through 9 and then just stuff that in there. And voila, you're good to go. So yeah, you can do that. So there you go. See, we're already growing as the ability of things that we can do. Okay, so dot. Oop, I think I used the brightness there. There we go. Dot is useful for a placeholder. It's a placeholder character. Good for misspellings, things like that. The potential disadvantage of it is that it can be anything. Like you have no control over what it can be. For that, you have to use the square brackets. Okay? Another one that is kind of neat is the hat symbol. So the hat symbol is something where you request that it starts with something. Okay? So it can be used in combination with the dollar symbol, which is ends with, starts with. And so, you know, if you're looking at strings that start with something specific, then it'll return those strings. There are other ways of writing this using the clean star, I suppose, but you know, this is all about flexibility, because otherwise you could just do this with the three things that I showed you with the regular express, like the grammar, with the, you know, the alternation and the clean star and the concatenation. So we're trying to make life easier by having additional symbols. So for example, if you wanted to find out all strings that start with the word mxt, like all serial numbers per se, then you could write something like this. And so this would look in a string for all the sentences per se that actually start with this. And how does it separate the string into pieces? With white space. So if your string is just all text all crushed together and there's no white space at all, and by white space, what am I talking about? I'm talking about spaces, tabs, line feeds, that kind of thing. So if everything's crushed together and everything is one single thing, and if the first one doesn't start with this and doesn't find it, that's the end of that. I'm saying if you have things spaced out with spaces, each one is going to check if it starts with this, and if it does, it will flag it and return you that string and its location if that's what you're looking for. Okay? So ends with is the same thing. Like it'll look at the end of a string before white space appears in the text and look for that. So you would write something like, let's say you're looking for everything that ends in the words X, Y, Z. Then what you would do to this string is you would put a $sign here and say, I would like all strings that end with X, Y, Z. So if you have something like, hi, I am happy X, Y, Z to be here, X, Y, Z, period, LOL, and that's it. Then it would actually find this happy XYZ, and that's it. It wouldn't find this one because it has this little dot at the end that screws up that string, so it doesn't end with that technically. So you have to be careful about those kind of tricks. Okay? So we got the square bracket, we got the dot, we got the hat, we got the dollar symbol, we got the asterisk. Let's move on to a couple of variations on the asterisk, which we will start with the plus symbol. So the plus symbol is almost the same as the asterisk with one exception. It does not include that empty string. So remember the clean star includes the empty string and then one or more repetitions. This one does not include the empty string. That's the only difference. So whereas this is 0 or more occurrences, this is 1 or more occurrences. Okay? So I'm saying you must have at least 1 or more occurrences there. So if I'm looking for like the same thing as hello before, and I have the star and the exclamation point, and I compare that with a hello that has a plus, I'm saying in this one, this could be anything, including nothing. This one, there has to be something there, 1 or more things. So it would find, you can rewind the video to see the other things that we had, but it would find all the combinations that we had before with the exception of this one. This one it would not find because this one has nothing there. This one just says hello, followed immediately without space of the exclamation point. So it wouldn't find that. Okay? It has to have something in there. It doesn't care what it is. It could be hello PT or hello P or something, but it has to have something. That's really the only difference between them. One of them has nothing there, and one of them has one thing or more. Okay? Another variation of these is going to be the question mark. The question mark stands for 0 or 1. So like, whereas the dot, in this case, it's kind of more like the dot. So whereas the dot says like something has to go there, it can be anything, but something has to go there. This is like the optional has to go there. So like something can go there, but also it doesn't have to go there. So if I'm looking for like tag, and then I have a question mark there, I am looking for any words that start with tag and either just end the word with the word tag, so with the G, or there's one more letter in there. So like it could be like tags. So it could be useful for when you're searching for things whether they're singular or plural. So there you go, that's one example of that. Yeah. Just want to see where I'm at with the recording time. Okay. We are nearing the end, so we will just keep going. And like I said, the next video will be focused on actually playing with some of these and running some examples. But I welcome you to try some on your own and just explore it. And it particularly gets fancy when you combine all these symbols. It looks like, it just looks weird, but it's pretty cool. Okay? You can do things like the curly braces, like if you're doing a function in Python, and then in there you put the number of occurrences that you want for something. Okay? So are you looking for 1 occurrence, 2 occurrences, 3 occurrences, 50 occurrences? How many do you want? So if you want 5, you put a 5 in there. And so you would put a term like RE, regular. And so that would have potentially 5 things that you could go have in there of what you're looking for, basically. Okay? So like, in a way, it's a little bit like the dot, because it could be any character technically. But the difference with the dot is that the dot could be white space in theory, like it could be space, whereas this has to be like a normal character. Okay? So like, this could be like 1, 2, 3, 4, 5, regular. That would get flagged as okay, like it would be matched. Basically anything here that has this format. But it has to have exactly 5. There's no variation, okay? Just because we have it in the regular expressions that we showed you earlier, there is that vertical line that is the OR. So you can always search for like this is a particularly cool one. It's like I'm looking for the word hello or hi, or I could put other greetings there. So every time there's a greeting match, it will actually tell me where that greeting is, regardless of the type of greeting, because I can list them all with ORs. So, yep, that's I think that's all of them that I want to show. There is parentheses, which works kind of the same way with the grouping, but I'll leave that for next time. So, yeah, there's more sequences and things, like special sequences, but I'll see where we at in time. We're at 54-minute mark. Do I want to show you sequences? Maybe I'll show you 1 or 2, and then I can let you explore those on your own. And like I said, we'll program a couple next time. So let me stand up and clean this. Yeah, this board is a mess. Every time you clean it, it just generates a lot of dust. I think that might be what's making my stomach hurt, being like poisoned by Sharpie dust. Tell me if you appreciate this method or if you prefer the iPad. If you prefer the iPad, then we can just live with the iPad. But I thought this might be a little bit more interactive, so thought I'd explore it for this class. Let me know what you prefer. So special characters or special sequences. I mean, actually, well, there is one more meta character that I mention, and that's where all the other ones are born, and that's the backslash. Maybe that backslash is a little bit too slanted. Okay, we know what that is in programming, right? So like, technically, you know, when you're writing like \n, we know that means line feed, right? I think that means tab, and then of course, if you want to use quotes, you can use that as an escape sequence, right? So that's what it means. It's an escape sequence character. And so you escape special characters this way. Now those special characters that you can escape vary. So for example, let's look at this one, \d. So \d is a special sort of signal to the regular expression that you're looking for something that contains a digit. Okay? So if I write a regular expression like this, what I'm saying is I am looking for anywhere in the text that I'm feeding into the string, I'm looking for the digits 0 through 9. You know, any digits that match. Okay? What if you don't want things that match with digits? So like the complete opposite of what this returns. You use uppercase D for that. This is where people start to get confused with this stuff. And I will agree with you that, like, you know, you got to remember that uppercase is like the opposite of lowercase for some of these things. Like, this is usually where it contains this, and uppercase is where it doesn't contain this. So like the inverse of that. So that can be a pain. Okay? Now, how would you use this in the mixture of other things? So like, let's say that I'm looking for that serial number stuff. So, you know, MXT, and then I got a bunch of digits, right? So I could do something like that. And I think that would look for one or more digits. Let me see, or if it's just one digit. Well, probably, as long as there's one digit, I think that would return a match, if I'm correct. But if not, you could probably, yeah, see, special sequences I prefer to do on computer, because then I can actually test them out before I say something wrong. But yeah, that's kind of the gist of it, that you are able to sort of specify, like, unique combinations of things like digits and characters and white space and so on. For example, if you're looking for, which of these would be nice to show? Let me see. Yeah, some of these they get really complex. I'll leave a link if you want to see more of the documentation. But let's just go with the other simple one, which is the S. So we got lowercase s and uppercase s. So that will return true if the string contains a white space character, so it's like a space, a tab, and so on. And then, of course, the uppercase one is where it does not contain a white space. Yeah, and there's other ones like W, which is word characters, and it gets pretty nasty, and so on. So, yeah, like I said, next video, I will be sitting in front of a computer, and we can actually experiment these together, and I think that's the best way to learn them, because you try them out, you see if they do what you expected them to do, and if they don't, then you see why they don't, and you learn from that, so that you kind of start picking them up. But you have to practice them, because they can get pretty complex. But it's a lot of power that you can do there, and with that power, you're able to achieve like some really, really cool patterns. And trying to write the code equivalent for this is not only more work in a way and more coding, but this stuff is like, it's super fast. Like, it's scary fast. How regular expressions are really optimized by the library functions that implement them. So you can just you can get back these pattern searches in like a fraction of the time that if you're trying to code this with loops. So if you know SQL and how relational databases work and how those are so much better than like using loops, this is kind of like the string matching pattern identification equivalent of that. Okay, so hopefully you all appreciate regular expressions and respect them better. And after the next class, hopefully you all actually get to use them whenever you want to find some patterns in text. So with that, I'm going to sign off. Thank you all for watching, and until next time, take care.